Hello everybody and welcome to the internet. We've got our linear functions here. So what we're going to be taking a look at is the special relationship between rise, run, and slope. So we're familiar with this notation, slope is equal to rise over run. Now we're also going to use one of these handy dandy triangles here. Now how many people recognize these kind of formula triangles from science? Awesome. So this is given you in the form of like F equals ma, or the distance, speed, and time equations. How many people are familiar with how this triangle works? Okay, let me do a little bit of a review. So the idea is that from this triangle we can derive the three equations here. So slope is rise over run, rise is slope times run, and run is equal to rise divided by slope. So in order to use this diagram, you have to use an incredibly powerful piece of technology called the thumb. So what you do is, for instance, if I want to find out what the slope is, I take my thumb, or in this case my hand, because it's big, and I cover it up. Now what am I left with?
Rise over run.
Rise over run. So the idea here is that you cover up what you're trying to find, and then what's left tells you what to do. So when two things are side by side, we multiply them. And when one thing is on top of another, that implies division. So here, if I cover up run, I can see that what I'm left with is rise divided by slope. And if I cover up rise, I'm left with slope times run. Okay, so this is a handy diagram that you want to make sure that you commit to memory. This is the relationship between rise, run, and slope. Now, it doesn't matter if you put run then slope or slope then run. The order of these two doesn't matter. What's important is that rise is on the top. So any questions with that formula triangle? Yeah? Oh, sorry. Was it making sense though? Yeah. Awesome. Okay, let's take a look at a question based on this. So, I think my little guy's going a little too long. Let's just, there we go, that's better. Okay, so here's our example. So a lean-to roof needs to have a slope of 5 over 9 and a length of 18 meters. We want to determine what the height of the roof is. So this is a rise, run, and slope question. Now, a lean-to roof kind of looks like this. It's going to have a line that comes down like this guy. So basically like a big right-angled triangle. So did you have a question? No? You doing okay? Okay, just wanted to check. All right, seem a little distracted is all. Okay, so this function here, this equation of triangular proportions is useful when we know two of the things and we're looking for a third. So in this case, we know the slope. So we've got the slope is 5 over 9. And what does this 18 meters represent? Is this the rise or the run? Yeah, this is the run because it's a length, right? It's like the horizontal distance. Now, what does the height represent?
Rise.
Yeah, this is your rise. I'm just going to use a different color here. Different color. There we go. So our rise is the height. Our 18 meters is the run. And our slope, well, slope is just the slope. So we're going to use our equation here, or our equation generator triangle, to help us out. So I'm looking for the height here. I'm looking for rise. So rise is equal to what? What's the equation for rise?
Slope.
Yeah, slope times run. So I've got slope times run. So now, what's slope in this case? What's the value of the slope? 5 over 9. What's the value of the run? 18 meters. So if I have 5 over 9 times 18, what do I get? 10. And what units will this be in? Meters. Beautiful. So what this says is the height of the roof will be a total of 10 meters. Okay. So any questions with that one? Marco, you doing okay?
Yeah.
Okay, is that making sense though? Okay. So any questions with this example? All right, let's move on. So, example 2. Oh, and for some reason, this is These sentences, they just kind of go off the screen. I think it's because I have a slightly bigger monitor at home, so my gotta make sure they're in the right format. So example 2. So we've got a wheelchair ramp requires a slope of 2/15 and needs to have a vertical change of 4 feet. Will a horizontal length of the ramp of 28 feet be long enough? Okay, so we're asked that if I have a distance vertically to cover of 4 feet and I only have 28 feet to do it in, is that ramp going to meet our requirements? Yes, sir.
Is that giving us 2 sides?
Well, think about what it's giving you. So here, let me draw a diagram. So let's just draw our little wheelchair ramp. Okay. So, whoop, like that. So what is the vertical change that we have to cover? What's the distance?
4 feet.
Yeah, 4 feet. Okay, what's the horizontal distance that we have available? 28 feet. Whoop.
Why don't you
And what we need is we need a slope. We need a slope less than or equal to 2/15. So our slope cannot be greater than 2/15. So there's actually 2 different ways that we can go about solving this. Well, not Pythagoras, because remember, slope is the rise divided by run. I don't care about what the distance is. So actually you bring up a really good point. You would use Pythagoras if I was looking for the length of the ramp. What we want to know is like the slope of ramp. So who here has ever had to have like been in a wheelchair for a time, if you broke your leg or something like that? Okay, so if you're in a wheelchair, is it really easy to go up like a really steep slope? If it's not motorized, it's arm power. So for instance, would it be easy to, roll up the hill to school? No, it's hard, right? So that's because you're super strength though. So take a look here. So for wheelchair ramps, they have to be at least a certain slope, okay? So, they have to have a maximum slope. So if they're too steep, people can't get up them, okay? So here, our slope has to be less than or equal to 2/15. And this is the first way we're going to take a look at solving this problem. So let's do a comparison. What's the slope given our 2 measurements? What's the slope equal to? Yeah. So 4/28. And what does 4/28 simplify to make?
7.
Close. 1/7, right? Because they're both divisible by 4. So you get 1/7. So now we need to do a comparison. Okay? Is it true that 1/7 is less than or equal to 2/15, or is it greater than 2/15? Who's bigger, 1/7 or 2/15? So and how could you figure out? Yeah, put them into decimal form, exactly. Okay? So put it into your calculator. Okay? I want you to figure out what's 1 divided by 7 and 2 divided by 15, and to see which one has the larger decimal. Okay, so who's bigger? Nope, it's good. So what we find is actually, Isaac, if you can give me the decimal, what'd you get for 1/7?
0.1428.
Yeah.
5715.
And then it repeats, right? So what we find here is, 1/7 is actually bigger than 2/15. So will a horizontal length of this ramp be enough? No. So yeah, exactly. So it's almost, but not enough. So the idea is that because our slope is steeper, and the idea is that the larger the numeric value of your slope, the steeper it is. So because our slope is steeper than 2/15, we don't have enough room. There isn't enough room. Okay, so we're using the idea of rise, run, and slope here. Okay, what's another way that we could solve this question? Does anyone think of another way we can solve this same question? a different comparison, let's say. Yes, sir?
See if you take. Wait, never mind. I don't know.
Yeah.
Get the denominator.
Equal denominator, kind of on the right track. Here, let me show you what I'm thinking here. Okay.
I got it.
Yeah. What do you got?
If you take the rise and the slope.
Yeah.
It's equal to 28. If it's equal to 28.
Exactly. So we're going to do exactly what Caden suggested here. So what we're going to do is I'm going to say, okay, I want my slope to be less than or equal to 2 over 15. So what we're going to do here is I'm going to see what run would I get if this matched, right? So what's the longest run I could have for a slope of 2 over 15? So if I'm looking for run, what's run equal to? So look at this diagram here. So what's the run equal to?
Rise divided by slope.
Rise divided by slope. So let's go back here. So run is equal to rise over slope. So let's see what we get. So I have a rise of 4 feet divided by a slope of 2 over 15. So I want you to put this into your calculator. What's 4 divided by 2 over 15? What do you get? Yeah, sorry, say it again. No, I think you got to use your brackets. Just remember it's 30. So just remember, so here when you're putting it into your calculator, you can do like 4 divided by bracket 2 over 15. So we'll get, this is 30 feet. So do we have enough room? We need 30 feet in order to do it. But do we have 30 feet available? No, we only have 28. So these are the two different approaches that you can use to answer this question. Well, it really depends on which one makes the most sense to you, right? So the idea is that, remember in mathematics we have what's called multiplicity. So you always have multiple pathways to the right answer. You just have to find which one makes the most sense to you, and kind of stick with it. Yeah, but that's a nice thing because you always have choice and you have creativity, and those aren't things we often think about when we put math together.